Okay, AP Chem, today we're going to learn about double and triple bonds and when you would need to use them. So we're going to start off with some simple examples. We'll start with one where we need just a single bond, and you're going to see why. Chlorine has 7 valence electrons and only wants to have 8, so it typically shares one bond. Chlorine is notorious for having single bonds. First thing we always do is add up the number of valence electrons that we have. That's exactly the amount of electrons we're going to represent. So I need to represent 14 electrons. I draw my 2 chlorines and I bond them together, which is going to use 2 electrons, and I have 12 left. Now notice when I split them up between the 2 chlorines and give them each 6, that's all the electrons that I have. Each of the chlorines has 8 electrons, 6 lone pair electrons, and 1 shared pair electrons. So they are happy. Now let's go to a situation where something else is going on. Each oxygen has 6 valence electrons. So I'm going to have to represent 12 electrons. Now oxygen has 6 electrons, so it is notorious for forming double bonds. Notice I only have 10 electrons left. I'm going to recognize if I split them up, it'll be 5 electrons each, and they're not going to be paired up. So that's, and each oxygen will then only have, so watch, 1, 2, 3, 4, 5. Each oxygen only has 7 electrons, so it's not going to be happy. So I don't have enough electrons to satisfy both of the oxygens unless I use a double bond. That's going to be 8 electrons left over, and I can split them up 4 more. Now each oxygen has 4 shared double bond electrons and 4 lone pair electrons, so each oxygen is happy. Now let's look at what happens with a triple bond. Nitrogen has 5 valence electrons each, so wants to share 3 more. So nitrogen tends to form 3 bonds, and sometimes that can be a triple bond. So nitrogen is notorious for having triple bonds. Notice when I bond him together, that's using 2 electrons. I have 8 left over. If I split those 8 electrons between the 2, each nitrogen's only going to have 6 electrons, and it won't be happy. So I'm going to use one of those to make a double bond, and you'll see that that gives me 6 electrons left over, and I would split them up and be 3 for each of them. That would be a total of 7 electrons for each nitrogen. Still not happy. So I'm going to notice that nitrogen loves to form triple bonds. And the triple bonds is going to use 6 electrons. So now we have 4 left over. The 4 electrons will be split between the nitrogens like such. And this is a triple bond. So let's recap what you do. You count up the number of valence electrons that a compound has. You write the elements down, bond them together, satisfy the outside elements, and then if you don't have enough electrons to satisfy each element in a compound with the 8 that they want, then you're going to use double and triple bonds. Let's check out some other compounds. First, let's add up the number of valence electrons. Each carbon has 4. Each hydrogen has 1. So I'm going to have 12 electrons total. I'll put my carbons in the center. Remember that carbon is notorious for being in the center. Hydrogens are a dead end, so they have to go on the outside of a compound every single time because they can't form more than one bond to link to 2 elements. So I'm going to bond them together with 2, 4, 6, 8, 10 electrons, leaving 2 left over. You see that right now each carbon has 6. Hydrogens are happy, so we're going to forget about them. Each carbon has 6. If I split those 2 electrons left over between the carbons, then each carbon will have 7. That's not going to be good enough. So I want you to have that red flag going. That's not enough. So I'm going to give a double bond here, and you'll notice that's the 2, 4, 6, 8 for each carbon, and 2, 4, 6, 8, 10, 12 total. And that's my compound. This compound is called ethene. Let's try another one. C2H2. So we have 2 carbons that each have 4, 2 hydrogens that each have 1, and that's going to give me a total of 10 electrons. So I'll put my carbons in the center like I did before, and put my hydrogens on the outside because they're dead ends. 2, 4, 6 to bond them together. I have 4 left over. If I split them between the carbons, each carbon will have 6 and won't be happy. So I'm going to give him a triple bond, and this one's called ethyne or acetylene. So this is just an introduction to when we use double and triple bonds, and we will continue to practice in class.